Okay, here we are with a question which is from the thermal physics part of the course. We're looking at a liquid which is heated at a constant rate in an open container, and we know the temperature of the liquid is rising by a certain temperature, and we know the time. We want to know the specific heat capacity, if I can say it, divided by the specific latent heat. Have a look, and when you're ready to watch on, have a look at the explanation. Okay, so we've got a bit of information here, all right? There's quite a lot going on here. Firstly, we've got the usual process. The temperature's rising by 0.5 degrees per second, and then we're boiling it and half of the mass has vaporized. Okay, so we want to know the specific latent heat capacity of the liquid divided by the specific latent heat. Let's have a look then. Firstly, we're going to remind ourselves that we're putting in energy, heat energy, that's going to be P times T, and that's equal to MC delta T. Okay, I've just changed it slightly. Usually I have Q here, but we're doing input of energy, so I thought it would be nice to have P times T. That's the total energy in there. Now, hopefully we can then rearrange there, and we're just going to put in some numbers. You can see that the specific heat capacity, which is one of the quantities we want, is the power times the time divided by the mass times delta T. Okay, now this is the sort of trick here. If we just get this right, we've got P, all right, we've got M, which is the mass, and then we've got this 0.5. Now what's this 0.5? You notice here we're going up at 0.5 degrees per second. So we've got delta T is 0.5 and time is 1 second. I probably should be a bit more explicit there. There's a times 1 here, we'll just ignore that. Now similarly, for our change in state, our PT is equal to delta M times L. And L is our specific latent heat of vaporization. So we can do a bit of maths here, all right? And again, there's something sort of similar going on here. L is going to be P times T, okay? And this time we have a different T, it's 10 minutes, okay? Time divided by delta M. Delta M is the change in mass. The change in mass is half of the mass, 0.5 M. So what I'm now going to do is put in those numbers, okay, after comparing numbers. So C over L is going to be this value here, capital P over 0.5 M, it's good. P times T, okay, in this case it's that 10 minutes divided by 0.5 M. You notice here our 0.5 M is going to cancel, and we're just left with 1 over T. Now 1 over T, T has to be expressed in seconds because we're using SI units here, and so we're going to have our T, 10 minutes, 600 seconds, which is why the answer here is A. Now there's a lot going on here, lots of little tricks to kind of cancel them, okay, and hopefully you followed it. Please let me know if not, and I'll see what I can do to help.